Hi guys, this is Achut. We are going to be looking at the linked list, what is linked list, and then what are the operations we are going to do in the linked list. Yeah, um, linked list is kind of like a sequential storage, like as arrays, but sequentially doesn't mean that it will be stored continuously. Suppose let's say in array there was indexes like 0, 1, 2, 3, 4, 5. But in linked list there won't be any indexes. There will be like it will be sequential, but it is not continuous. That means suppose if this is a node and then this is b node, so these are not adjacently stored. So suppose let's say this is head, then we cannot go to head of index 2. We need to go through the head and then we should call the pointer to the next, so that we'll get the b, and then for the b we need to call b next, so that we'll get the c, and then for c as well. So whatever the next nodes which are present to the next of the particular node, it will be stored in next pointer, and then at last there will be null nodes, so that if we reach at this point, then we can say the linked list is ended. So it will always starts from head, and then it will go till all the nodes are not present, which is represented by null. Yeah, and for particular node, if we consider like how we'll be implementing the linked list, there will be one node, and each particular node will have particular data. It can be like string, it can be it can be int, it can be anything, but it must definitely have node next, so that it will store the next data, next next pointer, which is next node to the linked list. That will be node on node pointer next, and this is the constructor we are saying. The data will be default 0, and then next pointer will be pointing to null, and then whenever we pass any data with the node, then we are going to assign the data, and then we are going to mark the next pointer as null. So this is the basic implementation of a linked list. Like if we precisely say that it will be a singly linked list, why? Because it has only one pointer, which is next, like this. So this is the basic implementation using the, this is just a node. And suppose if we take linked list implemented, linked list class to implement a linked list. So this is a linked list. So we have particular node, the class of particular node, and we need to implement this particular linked list. So what are the operations which we can do on linked list? Suppose let's say there is a b c, and then there is no d. So I want to insert d. So then we can say that we need to add some particular node at the end. This is some kind of insertion operator at the end, and insertion can be at some at the end and at the middle as well, like at some particular position, that is 0 1 1th position, and it can be at the starting itself. Suppose this is a, now I want to insert some z here at the starting, then we can say insertion at the end. So there can be different operations which we can do, like insert, delete, and then update with particular data. Yeah, and then we can delete all the data which is present in the linked list. So those are some kind of operations we can do on the linked list. So let's see one by one what are the operations we can do. Suppose let's take the linked list, and then it contains these particular functions. Let's say we take only insert node function to insert the node at the end of the linked list. This is one of the function we are going to implement, and then this function will implement all the nodes data, whatever the data which is present in the linked list. We are going to print that data here using this function, and then function to delete the node at a given position. Suppose let's say I have this particular linked list. Now I want to delete this particular node. If we want to delete this particular node, whatever the A next will be pointing to C, and then we'll remove this. So whenever we find B, suppose let's say A next equal to B, then we can say A next will become B's next. So we'll be pointing like this. That is how we are going to do. Let's see the code, then we can understand. So let's come one by one. Suppose let's say print list. For printing the linked list, see, there will be a head pointer, and then there will be, I think they did not mention any tail or anything. Okay, yeah, yeah, we have a head which points to the top, which points to the first of the node in the linked list. So if the head is null, then the list is empty. So we can just print that, and then we can return the function. And we were going to traverse the linked list by taking temp equal to head, and then we are going to traverse this linked list till temp becomes null. So whenever it becomes null, then we can say we came at the end, so we can stop there. So till that time we are going to output the temp data, and then we are moving temp to temp next. Suppose let's say this one, I'm going to output the A and then move to B, and then output B and then move to C, and then output C and then move to D, and then output D and then move to null. So whenever we see null, we are going to stop. That's what we are doing at this particular function. So let's say we want to insert the function to insert a new node. So when we want to insert new node, so we are going to create one new node, and let's say if the head is null, then that means the linked list is itself is not existed. So the only node which is going to be present is new node. So we are going to assign head equal to new node, and then we are going to return. Suppose let's say there is a head and we are going to insert at the end. This is not insert node, this is insert node at the last. So we are going to traverse till temp next equal to not equal to null. That means here will come, here will come, here will come, and then here D next equal to null. So here we are going to stop, and then after stopping there, we are going to assign temp. After we'll stop at that last node, and then we are going to assign temp next will be new node. Why? Because new node will be the last node which is present, and then we don't need to modify head. Why? Because that will be the first node which is present in the linked list. So this is a function what we use to insert a node at the end of the linked list. So let's consider one more case, function to delete a node at a given position. Let's say we are given a position and we need to delete that particular node which is present at that particular position. Let's take a temp1 and temp2 equal to null, and then we are going to take list whatever list linked list equal length equal to 0. Let's say if the head is empty, then we cannot remove the linked list in a linked list where it is empty, right? So we are going to say list is empty, we cannot do it, we cannot do anything. Then we are going to find the length of a linked list. How can we find the length of a linked list? We are just going to traverse till the end, we'll find the null, and then we are going to just increment the list length. So number of nodes which are present will be traversed, and then we are going to increase the length. That's how we are calculating the length. And here we are checking if the position to be deleted is greater than or equal to length of the linked list. Suppose let's say I have 5 nodes, and then let's say I give 6, then we cannot remove the sixth node. Why? Because the linked list size itself 5. So if the list length is less than the node offset, then we are going to say index is out of range. Suppose let's say it is in the range, then we can say we can delete that particular node. So let's take again temp equal to head and then deleting the head. Yeah, declare temp1 equal to head, and then we are going to say deleting the head, node offset equal to, yeah, when we say node offset equal to 1, that means we need to delete the head itself. That means we are going to delete this one. If we are going to delete this one, then what are we going to do? Head next will be this particular node, this will become new head. So but head next should be null. So we are going to take the next pointer here, and then we are going to make head next equal to null, and then we are going to take new head as this one. So they will be doing the same. So we are going to move the head equal to head next, right? And then delete temp1, whatever the temp1 which is present, like the starting one, that we are going to delete, and then we are going to just return. That's it. Why? Because we want to delete the first node itself. Now we want to, suppose let's say if it is not at, and if it is not out of the range, then it is going to be in the middle or at the end. So we are going to traverse through all the nodes. Suppose let's say no, node offset we are decrementing every time, and then we are going to take temp2 to temp1. That means we are going to store the previous pointer. Yeah, let me show. So this is one node, and then this is one node, and then this is one node. So uh, these are the three nodes. These are the three nodes, and then we are going to say this is this. And we are going to say temp1 will be the previous one, temp2 will be the previous one, and then temp1 will be the next particular node. So suppose let's say this is the previous node which we are going to store at this particular time. Till this particular time temp1 is also present here itself, but at this particular time we are going to say temp1 equal to temp next. So that means we are moving 1 to here for every position, and then afterwards, that means this particular node will be storing the previous one, and then this particular node will be storing the temp1 will be storing the current node, and then at last it becomes like uh, double equal to 1. That means node offset equal to 1. Suppose let's say I give offset equal to 2. Okay, so now at this particular time, for this it will be 2, and then again when it comes here, this will be offset, number of offset will be 1. So at this particular position it will stop, and then we'll come here, and then we'll come here, change the temp2 next to temp1 next. So this is the node we want to remove, the current node. So what we are going to do, instead of pointing next to here, we are going to point next to here, this particular node. So we are going to take the next equal to this one, and then we are going to delete this particular node which is temp1, which is the current node, and this is the temp2 will be previous node. So that is what we had did here. So this is a, these are the basic operations. You can go through this code. This will be, I'll be sharing the link. It is very easy, so you can go through this. First, what are the different operations we can do? The one operation is we can print the linked list, that is A, B, C, D till we find the null. And then one more operation is we need to add at the end. So if we want to add at the end, suppose let's say if the linked list is empty, then we are going to add only one node. And if the linked list is present, then we are going to traverse till the last of the node, and then we are going to say last node equal to the current node, whatever new node is created. Suppose we want to insert. When we are inserting, we need to take care of some of the conditions. Some of the conditions means like edge cases. Suppose let's say the node we want to add at this particular position, like out of range, cannot be uh, yeah, insertion we are not taking the position. Why? Because we are saying it is end. For deletion we are going to say indexes. Suppose let's say it is out of range, we want to delete at this position, we cannot delete. Why? Because we don't have a node at this particular position which is out of bounds, that is greater than this particular length of linked list. And if it is head, then we are going to move this head to here, and then we are going to delete this particular node. And if this is at this position, suppose let's say this particular node we want to remove. So what we are going to store is, we are going to store the previous one, and this is going to be the current one. So instead of pointing P next to here, we are going to break this, and then we are going to point here to C next, C current next, we are going to point. And then as we do not want this node, we are going to delete this node. Yeah, that's those are the those are the different operations we can do on single linked list. Yeah, that's all for this video. Thanks.